Good morning. Now I'll be looking at modular arithmetic, also known as remainder arithmetic. Now under modulo, what do we say? We are saying that it is a remainder after dividing an integer by a given modulo. After dividing an integer by a given modulo, the remainder that you get is the answer to the problem. Now let's look at this. These are the guidelines to our problems. Now to determine the set of a modulus, mod 1. Under mod 1, we consider the set of values of 0. So mod 1 has only one value. Mod 2 has two values, that's 0 and 1. Mod 3 has three values, that's 0, 1, 2, except the value itself. So you can clearly see that mod 1 we don't have 1 here, 2 we don't have 2 here, mod 3 we don't have 3 here. So with this, mod 4 is going to be 0, 1, 2, and 3. And let's say mod 5 is also going to be 0, 1, 2, 3, and 4. So if you are given any problem, the answer you are going to get will always lie within this range. Will always lie within the range. So if you are working in mod 4, your answer is either going to be 0, 1, 2, or 3. If you are working in mod 5, your answer is going to be either 0, 1, 2, 3, or 4. Let's add mod 6 to it. So we start from 0, 1, 2, 3, 4, and we end at 5, except the value itself. Now to find a mod n, this is the theorem. To find a mod n means that divide a by n. So we say a is a dividend, n is a divisor. So when you divide a by n, we don't need a quotient. All what we need is a remainder. All what we need, assuming a divided by n is k remainder k. If k is the remainder, then the answer to this problem a mod n the answer to this problem is a equal k mod n, where k is the remainder when you divide a by n. So if you are given any problem a mod n, just divide a by n. The answer you get, the remainder you get, becomes your answer to the problem. And that remainder, that k must satisfy this value. It must be in the set of values of n, where k is coming from n, or k can be seen in n. Now the next theorem we are going to consider is that if the dividend a, let's say if this value a is less than the divisor n, the next theorem is saying that if the dividend a is less than the divisor n, then the dividend remains the answer. So we are trying to say that if we are given a mod n, if this a is less than this, then the answer to this problem is the same as a mod n, where a is less than n. So if you have any case like that where this value is less than this value, then the answer to the problem is still a. Again, let's add this note to it. The answer to every mod must satisfy the set of values of the given mod. So let's say the answer to every mod must satisfy the set of values of the given mod. So let's start with some few examples let's say finding the modulo of a given number. So let's start with these few examples. Let's say 5 mod 3. 5 mod 3 means that we divide 5 by 3. So let's divide 5 by 3. 3 goes into 5, 1, remainder 2. So the answer to this problem is 5 is equal to 2 mod 3. We are interested in the remainder. Okay, that's the only thing we are interested. So the remainder is what we want. And you can clearly see that mod 3 is 0, 1, 2. So 2 can be seen in this set of values. Let's look at this next problem. If you have, let's say 7 mod 4. 7 mod 4. Mod 4 is 0, 1, 2, 3. So 7 mod 4. Let's say 7 divided by 4. That's 1, remainder 3. So 7 mod 4 becomes 7 equal 3 mod 4. So it's the remainder that we want. Now our next example is 27 mod 5. 27 mod 5. 5 goes into 27. 5 times remainder 2. So 27 mod 5 becomes 27 is equal to the remainder 2 mod 5. The next one, let's look at this example, 2 mod 3. Now because 3 cannot divide 2 and 2 is less than 3, we realize that one of the theorems told us that if the dividend is less than the modal value, the divisor, we write this as our answer. So since 2 is less than 3, 2 mod 3 is the same as 2 mod 3. So that's how it works. Now let's move on. Let's look at 42 mod 9. 42 mod 9. 42 divided by 9. 4 9 is 36 and 5 9 is 45. So we can't go for 5, so we go for 4. So 4 times 9 is 36, remainder 6. So therefore 42 is equal to 6 mod 9. So that's how it works. Now you can try your hands on these few examples from A to J. 27 mod 24, 18 mod 6, 53 mod 10, 32 mod 8, 84 mod 5, 6 mod 3, and 7 mod 9.